Hello everyone, I'm Elmer Akas, a reporter from Group 6. Instruments used for measuring force and for experiment on motion. The term force is common in every language. Interestingly, in its use in physics, the force can be only defined by the effect that it has on one or more objects. Force is vector quantity explained by its magnitude, direction, and point of application. For the linear motion of particles or rigid bodies, only the direction and force magnitude is important. However, the point of application is critical if you also put consideration in the angular motion. Furthermore, although the concept of force vector leads one to consider a point of application, in reality, direct contact spread over finite area rather than a single point is generating more external forces. This introduced the concept of pressure, that is, force distributed over an area of contact. A force measuring instrument thus consists of a force transducer and a display on which the measured force can be read. The measurement of force takes place on a tension or compression force. The areas of application of force measuring instruments are widespread. They are used in automation, in lifting systems, in manufacturing plants, in laboratories or mobile applications in the automotive industry. Since a force measuring instrument combines the measuring component and the display unit in one, mobile use is particularly frequent.
These are the instruments for measuring force and for experiment in motion.
Hello, my name is Mel Buchlian M. Bautista, and the next instrument used for measuring force and for experiments in motion is compression force transducers. Compression force transducers is reliable and robust. Compression force transducers are designed for determining compression force and are suitable for static and dynamic measurements in the direct force flow. Force transducers are manufactured from stainless steel and other high-quality materials, are robust, and are notable for their reliability and high quality even in complex applications. Our compression force transducers are available in different nominal loads. They cover a wide range of application areas. For instance, these force sensors are employed in machine building or in the automation of plants to determine the pressing and joining forces, as well as for detecting weight in many industrial applications. You can select the pertinent technical and regional approvals as options. And that's the compression force transducers.
Hello, I am Richard Fortuna, and I'm going to talk about the bending and shear beams. Bending beams and shear beams are used for the determination of forces and are suitable for both static and dynamic measurement projects. To determine how strong the force is in the application, strain gauges or thin film sensors are used, which are attached on or in the measuring body. The field of application of the bending beam and shear beam are many and varied. It is often used in industrial weighing technology as well as in the areas of special machine building, factory automation, and stage construction. In addition, they are used in the laboratory and process industry for the indirect determination of torques. The appropriate technical and regional approvals of these force transducers are, of course, available as options.
Good day everyone, I'm Jonathan Icola. So for today, we are going to tackle the topic entitled load cells. We're excellent quality from Wika. So what is load cell? A load cell is a highly accurate device that is used to measure weight or force in a number of different applications. They can be used to measure compressions, tensions, bending, or shear forces. Load cells are designed as a special form of force sensor. For use in weighting equipment, this force sensor enable very high measurement accuracies between 0.01% and 0.05% fs. The calibration of load cells is made in grams, kilograms, or tons, not in newton. Load cells are used in the widest variety of applications area, including platform, filling, band and packaging scales, dynamic test systems, and so on. Among others, Wika provides you with all typical and widely used load cells geometries such as bending and shear bend load cells, S-type load cells, and compression force load cells, just like I said a while ago. In addition, there are corresponding mounting kits and complete weighting modules that are available in Wika.
The next one is the load pins.
A load pin is a type of load cell that can replace clevis, sheave, pivot, equalizer pins, and other bearing components. Load pins can be used in cranes, winches, elevators, hoisting gear, sheaves, shackles, bearing blocks, and pivots. Load pins are internally gauged with a board center containing force measuring strain gauges. Like other load cells, these strain gauges measure the change in electrical signal caused by force, which is then converted into weight measurement. The load pin exterior has two grooves defining the area of the pin between measured forces. Any industry with overhead equipment requiring safe operating conditions can benefit from a load pin, including agriculture, chemical processing, energy production, marine cargo, and port shipping operations, because load pins are made of corrosion-resistant stainless, and the strain gauges are completely internal. They can be used in almost every environment. The last one is the tension links.
What is tension link? Tension links are designed for static and dynamic measurement tasks in the direct flux of force. As a load-bearing component and existing constructions, they determine the tension forces in a wide scope of application. We often use the tension link in hoist and crane systems as torque support for load measurement. Further applications areas are special machine constructions in polymer processing machines. And why do we need tension link? To ensure the safety in the movement in the sites, and also to ensure safe operation and prevent overloading of machinery. In that way, the safety in the construction sites can be first-rate quality. Palisok Hazel Angeli, Group 6, Instrument 7.